Between absolute scarcity and abundance. The great challenge of the 21st century is to raise people everywhere to a decent standard of living while preserving as much of the rest of life as possible. Before we dive into the wonderful world of economics, let me start this lecture on the economics of biodiversity conservation with a brief description of what is understood with biodiversity. The term biodiversity was popularized by biologist Edward Wilson and refers to the biological diversity of life and can be understood as the diversity at the levels of genes, species, and ecosystems. This broad division ignores some forms or levels of biodiversity. One can make an argument to include interactions between different populations and their ecosystems, culture, or landscape geodiversity. Before I try to appeal to your heart for as to why it is important to conserve biodiversity, let me first appeal to your reason. Biodiversity makes ecosystems more efficient. As a general rule, reductions in the number of genes, species, and functional groups of organisms reduce the efficiency by which whole communities capture biologically essential resources, nutrients, water, light, prey, and convert those resources into biomass. And biodiversity makes ecosystems more stable or resilient. Ecosystems that depend on a few or single species for critical functions are vulnerable to disturbances such as disease and at a greater risk of tipping into undesired states. Moreover, in recent years, a consistent picture has emerged. Biodiversity loss tends to increase pathogen transmission and disease incidence. Finally, preserving biodiversity gives next generations more tools to overcome problems of their own, as nature solutions often lie at the basis of innovation. What motivated me to write these lectures is that we are losing species at an alarming rate. For example, our amphibian friends have witnessed at least 10 members of their class going extinct over the last 30 years, including the fairy tale-like golden toad, gone forever. The loss of 10 species may not sound like much, but extinctions are rather rare events during nature as usual. With roughly 6,000 recorded amphibian species, one would expect about one extinction every 160 years to 1600 years. In other words, the recent amphibian extinctions are at least 60 to 600 times the natural rate. Survival of the fittest, you may say, but the group of endangered species is not limited to slow and colorful toads. Many powerful, fast, and smart species have suffered significant population reductions during the last century. Take, for example, the blue whale population that is depleted by at least 70% and possibly as much as 90%. The tiger population of mature individuals may be fewer than 2,500, or the orangutan decline of 80% over the last 75 years on Sumatra and well over 50% during the last 60 years on Borneo. The Worldwide Fund, WWF, reports that global wildlife populations had declined to half of their 1970 levels by 2012. The decline in species abundance may be even worse for insects, as Hallman and colleagues found a 75% decline between 1989 and 2016 in the flying insect biomass within German protected areas. Currently, the heightened rate of extinctions is such that we may be losing about one species per hour. If you could be another species for a day, which would you choose? I would choose the... Let us see how fast you can guess my choice. I'm among the select group of species that has been to space. I have an incubation period of about a week. After I hatch, I increase my weight 2,000-fold in a 2-week feeding frenzy, followed by a fortnight in emerald-colored sheets. As an adult, I have a wingspan of 10 centimeters and weigh less than a gram. My wings are bright orange with black stripes and some white dots. so I'm easily mistaken for a tiger. I can fly up to 50 kilometers per hour and 600 in a day, taking part in a multi-generational migration. Have you guessed it by now? My choice would be the monarch butterfly. How wonderful it must feel to emerge from one's pupa and spread one's wings for the first time, fluttering through the sky. Dancing like birds of paradise, carpe diem like a mayfly, taking it easy like a sloth, or having a bad day, there is still plenty of wonder to choose from. There are good chances that Edward Wilson would have answered the above question by choosing an ant species. Judging from his production and influence over our understanding of ants, he certainly had the work ethic of one already. His theory of island biogeography, joint work with Robert MacArthur, has been even more influential than his work on ants and earned him the nickname of being Darwin's natural hare. MacArthur and Wilson proposed that the species richness of an island is related to its size and distance from the continent. According to the theory, an increase in an island's isolation decreases the odds that species arrive by migration, and an increase in its size allows it to sustain more species. The theory refers to ceteris paribus increases in isolation or size. Ceteris paribus is a Latin phrase often used by economists to say everything else remaining constant. Obviously, there are more factors that determine the species richness on an island, for example, its climate or age. However, the theory holds that given a certain climate or age of the island, an increase in isolation decreases species richness. Wilson went through quite extremes to find evidence that supported their theory. Together with Daniel Simberlov, he turned 6 small mangrove islands in the Floria Bay lifeless by fumigating them. Wilson and Simberlov monitored the variety of species that recolonized these islands for a year, and in line with the theory, the island most distant from the continent remained least species rich. Since the theory of island biogeography has been extended to describe species richness of other types of islands, between quotation marks, such as desert oases, mountaintops, or fragmented habitats due to human influence. Not only has the theory been largely supported by empirical evidence, it also has practical implications for the conservation of nature. For instance, wildlife corridors may aid conservation by creating larger connected habitats. The theory of island biogeography may provide a peek into the future as well. Pim and Raven used estimates for species area relationships from the literature to simulate the loss of species in the coming century due to ongoing decrease and fragmentation of habitats. The estimates for the current extinction rates by Pim and Raven range between 500 and 2,500 extinction per million species years, depending on the scenario. Under their business as usual scenario, the rate rises to 5,000 by the middle of the century. Moreover, their analysis suggested that there is an extinction debt, that is, applying the species area relationship to individual hotspots gives the prediction that 18% of all species will eventually become extinct if all of the remaining habitats within the hotspot were quickly protected. If current patterns of human destruction continue unchanged, Wilson fears that half the species of plants and animals on Earth could be gone or at least fated for early extinction by the end of the century. Wilson is not alone with his grim outlook. Others have already claimed that we may find ourselves at the start of the 6th mass extinction event. The Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES, describes that human activities have altered most ecosystems and that these changes have already pushed a quarter of plant and animal life to the brink of extinction. Losses of both species abundance and species richness occur across geographical areas and taxonomic groups. And the global extinction rate is currently estimated to exceed the background rate by at least 2 to 3 orders of magnitude, and possibly more. The IPBES lists changes in land use, harvesting, climate change, pollution, and invasive species as the most important drivers of biodiversity loss. Now that we better understand this biodiversity challenge of biblical proportions, let us explore how studying economics may help to halt this worrisome trend of extinction.